watching Mr. Fugu Data Science. We're doing some pattern matching today with Postgres and Python featuring SciCopG2. I figured this video would be very useful for somebody starting out or just trying to get some basics or remember something they may have forgot, because pattern matching is very important, as well as trying to figure out how to manipulate functions within SciCopG2 that emulate command line utility, which is not straightforward. You need to throw in pandas scicopg2 from scicopg2 import SQL, as well as if you have your user credential file. If you don't, feel free to just try this out right here. Also, thank you to the recent viewers and subscribers. I greatly appreciate it, and I apologize for the delay in the video recently. I've been very busy. It's been very hectic. Now, I'm using my config file as storing my function with my key value pairs that I'm using to establish my connection. And further, I create a cursor allowing me the ability to send and retrieve data as well as read and write files. Please understand that I'm using auto commit equals true so I could have all this happen immediately, but do understand the downfalls of this and read the official documentation to get an idea. From our last video, we had two specific files allowing us to work with some car dealer data that we split so we could basically run a primary key so we could join the two tables. But we're not doing that today. We're going to feature these so we could run some queries, do some pattern matching, and try to establish changing some data type, because that's something that will come up, I guarantee you. For a future endeavor, I decided something because I'm really tired of hand plucking these tables that you create that are hard coded, and I'm going to show you what's going on. So let me show you something real quick. This is what I'm going to work on in the future. This kind of dragged me for a little bit of a loop, but here's the ID or the index, the VIN number, and some of these columns from our data frame, and I converted them into these data types that are usable for Postgres. But I'm trying to figure out a way that I could make a dynamic table where we can throw these in all at once, instead of writing this annoying stupid thing, which is useful for writing a couple individual columns, but it doesn't work if I have 100, 200, 1,000 columns. It's useless. Think about that in the future. If somebody has some great ideas or some links, send those my way. Now, I created these two tables so we could chuck our data in. I just subset these real small so we could just get an idea of what's going on. And I've used this in previous videos, but if this is the first time watching this, what I'm doing is I'm dropping this if it already exists. I'm creating an unlogged table, and here's the three columns with their data types or their schema. And then I'm sending that off. And just think of this with statement like a with open if you're throwing open a file. After it's done, you don't have to worry about allocating resources or closing this out unless you're closing your connection. Now, I did the same thing for the second table, which is fine and dandy. It's just a little bit different in data. And what I wanted to look at first is if you were looking at Postgres, all you have to do, if you're looking at Postgres, this is all you have to do to describe a table, all right? And we can see what the data types are. But you just can't do that when you're using SciCopG2. You don't have the same utility that you do in a terminal. So you have to do a little funky manipulation. And so for instance, you have to select table name, the column name, and then it's calling in your data types from the schema.column. And then right here, what's going on with these brackets is I'm using the SQL portion from SciCopG2. I don't know if I imported that in earlier, but you'd have to do something like this from, and you'd have to just call in SQL. All right, that's what's going on here. And this is allowing me to do some specific formatting where I'm able to call these in as parameters. And I'm doing a formatting down here. We went over this in the previous video, but if you didn't see that, you had two distinctions. One is a literal form, the other is an identifier. Identifiers deal with columns and tables. Literals deal with direct string values. So what I did was, I found this on Stack Overflow, I think it was, but you're just calling in your table and it's basically printing out from this template form right here, which is non-specific information, but it's allowing you to get a printout of your specific table and each column and their specific data type, which is very useful if you need to do any kind of manipulations. For instance, if you had to change one of these data types, this would be something you like to use instead of having to go back and forth between the terminal. But that's just an option, all right? Now, I decided to subset our data since we're going to be sending it off and calling it as .value, since we're going to take our data frame and we're going to send this off to Postgres. I did this in my first video. But what's going on here? Making sure at least you have something for your data frame. and this data frame will be as a list. You have the 3 parameters or arguments here. That'll be your data frame, the table you want to send it to, and then the cursor that's going to send this off. All right, and you're just turning everything into a string join from your list that you just created above. And we're doing some formatting where we're taking our values as our input right here through our little curly braces and using our placeholder. All right, this is something you should be aware of and leery of for security purposes, because things like this would be more suitable where you have whatever your name is and then you throw in the S. That's one designation, or you can just do like this, because these parameters are known natively through Postgres, whereas you can have some issues if these were input statements or something like that on a website. Alright, so this is fine if we're just using our code, but if this is some kind of utility for a website or for business applications, just be leery if it's from outside personnel having access. Now, we threw this into our input statement with our 3 little parameters. Truncate is used so you don't have issues with duplicating your data. We're using our connection and we're sending this as a batch, so we're sending everything at once. Alright, now let's scoot over there. I'm using this select statement real quick so we can see what's going on. Notice that we have these 3 goofy looking things. This is what my VIN number is, this is the index value, and this is the corresponding model list for this particular vehicle. You can manipulate this later if you wanted to, since it's an array. Other file, which is our second part of the car dealership that we subset, will look like this. We're taking just the date of purchase, the VIN number, what kind of vehicle it's make, and its year. And let's consider changing the data type for our VIN number, which is a varchar, and let's convert it into an integer. And so you need to do the alter table, call in my table name, and then the column that I'm altering. And then I'm changing the type to an integer, and then I'm kind of forcing that, using this notation with the double colons. All right. And you can say, well, why am I not using a cast? Well, casting, I was trying that, but I was having some issues with the column actually changing. It wasn't changing the column. That's why I didn't show that in this example. But casting is another option that you have for changing the type. Now we can see that it became an integer, whereas before it was a varchar. If you ran this again, the same little formatting that we had above, so we could basically see our schema. And something that's really interesting and pretty useful is what's called Mogrify. And so if you needed to do some tracing back a few queries, like sometimes you get these errors and you're like, what the heck does this error mean? I don't know what's going on. I need to trace back how Postgres or SQL actually interpreted my query. And so basically, I'm calling in my cursor and I'm calling Mogrify and then whatever SQL statement that I had. And so since I ran multi-lines on my SQL statements, it prints out what would be read. So I'm selecting some table with some column, the data type, and then from the schema with my columns. And then I'm calling in the where clause and throwing it into my table of interest. And I did the same thing for the one we just did above. But this could be pretty useful, for instance, if you were trying to do some troubleshooting and throw this into your code for deployment. So I, for instance, run my query that I set up, and then I set up my Mogrify to read that in, and then I could throw that in my execute. And so now you actually have 1, you're trying to verify that the query looks correct, and 2, you are throwing it directly in the execute to have it do whatever you're trying to run. But now you have like a traceback method here to help you for debugging. Something that's pretty useful is like fuzzy matching of strings or things like that. So the first thing we're going to look at is an extension called trigram, and that's allowing you to do some string matching, and it's working on, I think it's 3 consecutive characters next to each other. So let's say that we're looking for a person, but we're not really sure, but we think that their name is like something like Aldo or something like that, right? You're like, I don't remember, man. I'm busy. Somebody called for some business or something I need to look up. Here we go. We create this extension real quick. We could do this outside of it first and then call in our select statement, but I'm running it all together. But if you run this again, it'll say that this is already established. So you either need to drop it and run this again, or take this outside of it when you're creating it. But anyway, you create this extension allowing you to run your trigrams, where I'm looking for the similarity of this person with the first name of Aldo in descending order, and it's just limiting 5 entries. Alright, so we have someone that's Alfredo, Ali, Alec, and Alex. Those are the closest that we have for Aldo here. Now, what about if we had parameters that we wanted to throw in doing the same exact thing, but letting you see what it looks like if you were actually inputting your table name, your column name, and then the name of interest that you had. We could run this the same with our SQL.SQL and throw in our formatting and do our column, which is the identifier. Our table and our column get identifier, and then the actual string name is just a literal, all right? We can do this little like confidence level basically of saying, all right, 0 to 1, how likely is it, these names that we're going to get are close enough to BOR for the last name, and the default value is 0.03. So the lower the number, the less specific it gets. All right, so you're going to have things that are not very close to this. All right, so the higher I go, we have nothing. But what happens if I do the default value? Oh no, we get a bunch of people. But look at this, box, not very close, right? So here's what we got for that. What if we have an alternate way, or wanted to do an alternate way? You can do it like this with the parameters that we just had, throwing in our table, our column, and the name. So it's not very hard. We could chuck this into a function if we're interested in using a function as well. But I'm trying to give you as many options and ideas as possible to help you out later. You could also do phonetic spelling. For instance, if you had an idea how their name sounded phonetically, but you didn't have a clue of how it was actually spelled, you can look that up too. For instance, this is interesting. This fuzzy string match extension is only working off of a conversion that it takes of your string and makes it into 4-letter codes. And then what it's doing is it's just matching those 4-letter codes. For instance, flour, let you bake with, and flowers, let you smell. Those end up having the same code because phonetically they sound similar. So if we were looking for somebody with Donnie A, we didn't know what was going on with this name. We just heard someone pronounce it weird. Maybe they're from a place that they don't enunciate. I don't know. And we look for this name using the fuzzy string match. And we're using the where clause where we're calling in this little library or function. I don't know what it exactly is, but it's called SoundX. And I'm taking my first name with whatever phonetic identifier I'm using and chucking that in and seeing what I get thrown out. And these are the names that closely match whatever I'm looking for phonetically. I didn't get too crazy here, but you could start spelling all funny if you wanted to or you weren't sure. But I do need to mention something. If you're using names that aren't English language names, you're going to have issues with matching these up. For instance, if you had like special characters or something like that over any of your letters, that's going to throw it off. And there's an example of this I left in the citations for the fuzzy string matching that you could look into further examples. So let's scroll down. You also got a tool which is called the Levenshtein distance, and that's just working on added distancing. So you're basically measuring how many deletes, inserts, and updates you have. And for instance, if we were converting long to length, you'd have to change the O to an E, which is 1. You'd have to also add a T and an H. And I think this would add up to 4 is what's going on. But you could do comparisons with this to figure it out. Now, I'm calling in my Levenshtein for someone named Donnie W. Again, we're just messing with that. We're just throwing in the first 5 of those in ascending order. And we see that we end up getting Tony, Ronnie, Dondre, and Don. Okay, fine. We can do some string converting and throw everything into a lowercase, and that's shown here. I just doubled it up so you can see the before and the after. We can do pattern matching using regular expressions. For instance, if I was looking for somebody that had either the first name of J or G in the beginning of their name, that's what's going on here. I'm looking for at least one occurrence of that. So now we have Justin and Juan and Joshua, and I'm only printing the first 5. Okay. We can look at using the like, I shouldn't say regex here because it's using this, but you could use like or I like, which is case insensitive. For instance, I'm trying to find the VIN numbers that start with 102 here, and I'm just converting it into a text, which was originally an integer after we formatted it above. And we can do, if we scroll, and we got 2 things when you're using the like or I like. You got to think about the operators. The percent sign is allowing you to match 0 or 1 occurrences. And then the underscore is letting you match like single letters. We're going to see both. So if we wanted someone with the last name that had Bega, and you're like, okay, I'm not exactly sure who I'm looking for, but the name is something like this. Let's see what we get for some results. Hopefully you don't have 10 billion of these people. And so it prints out anything that's very similar. Has at least what you're looking for with the Bega. you could throw an underscore and just look for EGA for the last name, which is almost the same thing, right? And what's going on here is it's taking those characters that are in front of it. There's something interesting here that's going on, and I didn't mention this. So we're finding anybody with EGA and any letters that are in front of it. Then what I wanted to do is a useful thing. When you're always printing off these stupid queries, right? Look what's going on. You don't even know what the columns are. That's why I did this. Because now you have the ability to select your table of interest, at least something to pop up. And you're going to throw in your description of what you're looking for your columns. And that's how I'm getting these column names from this list comprehension. Because it's basically iterating through this description right here, which is very useful and something you should consider. But as always, I'd like to say, please like, share, and subscribe. And if you subscribe, turn on that notification bell. I hope this brought utility to somebody. See you in the next video. Bye.